Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have x to the power of 4 is equals to 4 and we solve this problem for all the values of x. So here you see that this is fourth order equation. It means that this equation has 4 roots. So now here in this question we need to find all that 4 roots of this equation. So further we move toward the solution of this problem, and I hope so you like this method. But if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move towards the solution of this problem. So first we rewrite this equation as this is x to the power of 4. We write it as x square and its whole square is equals to this is 4. We write it as 2 square. Okay, so 2 square becomes here 4. And now here in the next step we move this 2 square from right hand side to the left hand side, and it will becomes x square and its whole square minus 2 square is equals to 0. And further in the next step here we need more simplifications, and it will be written as here we use the nice algebraic formula. You know about that. If we have a square minus b square is equals to a minus b times of a plus b. And you see here the base of this term is our a and the base of this term is our b. So when we use this nice formula, so it will be written as in this form. This will becomes here a minus b our first factor, so we write it as x square minus 2 into x square plus 2, and this whole equation is equals to 0. And now further we divide this equation into the two cases. The first case is we write x square minus 2 equals to 0, and the second case is we write x square plus 2 is equals to 0. And further in the next step we need to move this minus 2 to the right hand side, and it will be written as x square is equals to plus 2. And from here we get our x square is equals to minus 2. So here you remember one thing is that our target is to find the values of x, so that's why we need to remove this square sign. So in order to remove this square sign we apply square root on both of the sides. Okay, so when you know about that, when we apply square root on both of the sides we will be write here plus minus sign on any one of the sides. So this 2 and this square root are gone, and we get here in the left hand side we get x is equals to, in the right hand side we have this is square root of 2, because here we apply square root on both of the sides, so that's why we write here plus minus sign on any one of the side. These are the two real roots of the given equation which we get here. And now here from this case we again apply square root on both of the sides, and it will be written as in this form. So this 2 and this square root are gone, and you get here our x is equals to, this is a square root of minus 2, and here we apply the square root sign separately on both of these two values, and it will be written as square root of 2 into square root of minus 1. So here again when you apply square root on both of the sides we will be write here plus minus sign, and this will becomes here plus minus square root of 2 into, we know that minus 1 square root becomes here iota. So these are the other two complex roots of the given equation. So you see here we obtain these are the 4 roots of the given equation. And now here in the next step we need to verify that is all of these 4 roots be the solution, or all of these 4 roots be the extraneous root. For this we need to copy down given question statement. Here it is x to the power of 4 is equals to 4, and in this side we will be verify x is equals to plus minus square root of 2, and in this side we will be verify x is equals to plus minus square root of 2 into iota. Okay, so these are the here we need to verify all of these 4 roots. So here first we verify plus minus square root of 2, would put this value into the left hand side, and it will becomes plus minus square root of 2 and its whole square is equals to 4 or not. So this is the our claim. So here you know about that, sorry, this is the power 4. Here you know about that when we have our base is negative and its exponent is an even number, so this negative term is always becomes here positive. So we write this term as further we write this square root sign as into the form of exponent, so it will becomes 2 to the power of 1 over 2 and its whole power is 4, and this negative sign becomes positive because of even power. Okay, So you see here, these are cancelled out by each other, and we get 2 times 2 becomes 4, and this is equals to 4. So here we obtain 2 square equals to 4. So here you clearly see that 4 is equals to 4. This means that the value of x is equals to plus minus 2 is satisfied our given question statement. And now here in the same pattern, we need to verify this value. So when you put this value here, it will becomes plus minus square root of 2 into iota, and its whole exponent is 4 is equals to 4 or not. And now here further in the next step, you see here the base again negative and its exponent is even number, so this will becomes positive, and we write this 2 as into the form of exponent. Further, we break this exponent 4 separately on both of these two values. We apply this on this term and we apply this on iota, and we check that is this equals to 4 or not. And now again you see that this is 2 times 2 becomes 4, and we get here 2 square, and we write this iota to the power of 4 as iota square and its whole square, and we check that is this equals to 4 or not. So you get here 2 square becomes 4, and iota square equals to minus 1 square equals to 4, and we easily obtain 4 equals to 4 because minus 1 square becomes here plus 1. So this again shows that both of the sides are equal. So here we finally conclude about that the solution set of this problem is plus minus square root of 2 and plus minus square root of 2 iota. So these are the 4 roots of the given equation, and this is the final answer. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.